Hello viewers, we are looking at partial differentiation, and under partial differentiation we are going to consider this problem. And so if you look at the problem, we have z equal to x plus y divided by x minus y. And so if you look at it, it is in the quotient form. And so we are going to be applying quotient rule to solve this partial differentiation problem. And so in the problem, we've been asked to find partial derivative of z with respect to x and that of z with respect to y. And because it is in the quotient form, we are going to apply quotient rule in solving the question. So quickly, we see solution. And so we make a mathematical statement. Let u equal to x plus y and v equal to x minus y. And so if we've done that, if we differentiate v, so we say partial derivative of u with respect to x will give us 1, because when we are not going to consider y. So because we are differentiating partially, u partially with respect to x, it will give us 1 because we are differentiating only this. And then when we differentiate v with respect to x, it's partial differentiation and differentiation. So we should know this is in this one, so it will be 1, 2. So we have to also differentiate u with respect to y. So we say partial derivative of u with respect to y will give us 1 because we are differentiating this u with respect to y. So we have 1. And again, we'll also have, let's take it down here. So partial derivative of v with respect to y also, when we differentiate v with respect to y, this is y is negative, so it will be negative 1. So having done this, we can now apply our quotient rule to solve this question. Note for quotient rule, we'll have that our a to find dz over x, that's partial derivative of z with respect to x. So we applying quotient rule. So if we can apply quotient rule, dz over dx, partial derivative will be equal to v, partial derivative of u with respect to partial derivative of x, minus u, partial derivative of u, partial derivative of v with respect to x, all over v squared. That's what we are going to have. And so if we bring in the values, what is our v? Our v is x minus y, so we have x minus y, we put it in bracket. What is a partial derivative of u with respect to x? Is 1. So we have 1 here. We put this minus, and the next thing is our u. What is the value of our u? X plus y. So we have x plus y. And then what's the value of our partial derivative of v with respect to x? It's 1 here. So we have 1. Divide it by v squared. What is the value of our v? This is v, and this is the value of our v. So v squared will be x minus y, all squared. Okay, so we can now use this one to open the bracket. 1 times x will give us x, 1 times minus y will give us minus y. Okay, and then let's use this other one to open this bracket. Note we keep our minus and still keep this one inside bracket. 1 times x here will give us x, plus 1 times y will give us y. This will be all over x minus y, all squared. So we have to use this negative to open this bracket, so that we are going to have, okay, let's come to this side of the board. So when we use the negative, this negative to open this bracket, we are going to have that change partial derivative of z with respect to x will be equal to, we take our first x minus y, which is this one. When we use this negative to open this bracket, we are going to have minus times x will give us minus x, and then minus times plus y will give us minus y, and this will be all over x minus y all squared. So if we look at this is plus x and this is minus x, so this can cancel out, and so we are going to have partial derivative of z with respect to x equal to minus y will give us minus 2y all over x minus y all squared. You can decide to keep the answer this way. You don't need to really, it's not necessary to open the bracket at this point. So we've been able to determine dz over partial derivative of z with respect to x to be minus 2y over x minus y squared. So the second one is b. Now b, we have to determine in b, we have to determine partial derivative of z with respect to y using the same quotient rule. So our formula for, since we are dealing with y, our formula for quotient rule will now be v partial derivative of u with respect to y minus u partial derivative of v with respect to y divided by v squared. And so if we bring in the values here, what is our v? Our v is x minus y. X minus y, we put it in brackets. And change partial derivative of u with respect to y. From here is 1. From here is 1. So we have 1. We put a minus. Our u from here is x plus y. So we have x plus y. Put it in brackets. And a change in v with respect to y. Change in v, okay, see it here, change in v with respect to y, that is partial derivative of v with respect to y is minus 1. We close our bracket, all over v squared, and v squared, this is our v, so the square is going to be x minus y all squared. And so we can now open the bracket, so this will give us 1 times x is x, 1 times minus y is minus y. We keep this minus and use this first to open this bracket. So minus 1 times x is minus x. Minus 1 times plus 5 is minus y. Okay, minus 1 times plus y is minus y divided by x minus y all squared. So at this point, we can now use this to open the bracket, and so we have x, okay, let's go to this other side. So we have x, there is a change in partial derivative of z with respect to y equal to, we have x minus y. Now if we use this negative to open this bracket, this negative times minus x will give us plus x, and this negative again times minus y will give us plus y. So we divide it by x minus y all squared. So x minus y all squared. So if we look at the expression on the right hand side of the equation, we have that this is minus y and plus y, so this will cancel out. And x plus x, this x plus this x will give us 2x all over x minus y all squared. So basically, this is how to solve this question. We've gotten an answer, and the answer is 2x all over x minus y all squared for the partial derivative of z with respect to y based on the question we are considering. Now at this point, you can also find the partial derivative square of z all over that of y, partial derivative of y square. You can also find it using the same quotient rule, where you have to make this your u and make this your v, and then you solve down So basically that's how to solve the question of this